Go down to your neighborhood Circuit City and buy a video game console, and when you take it home, all you have to do is plug it in and play with it. Would that it were so easy when it came to PCs. If what you bought at the store was one of these multimedia upgrade kits, it could take you hours, maybe days, before you get your new soundboard and your CD-ROM drive speaking the same language as your PC. But all of that is coming to an end now with a new expansion standard called Plug and Play. Today, we'll show you that adding a peripheral to your PC is now as easy as, well, a Macintosh. Plug and Play on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by Hewlett-Packard, working with industry leaders to ensure compatibility across the board and across the network. HP PCs, you're looking at partnership in a whole new light.
The Computer Chronicles is also made possible by the Software Publishers Association, providers of educational materials to help manage software. Don't copy that floppy.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me today is Tom Halfhill, Senior Editor with Byte Magazine. Tom's the author of this recent Byte cover story on Plug and Play. Tom, I just bought this multimedia upgrade kit, and I've got, let's see, this nice fat manual. I've got 5 installation discs, a board I've got to install, all kinds of interesting cables over here I got to figure out what to do with. We know how complicated it can be to install peripherals on a PC. You've got a Macintosh set up here, and I want to compare it to the Mac situation. Here's a CD-ROM drive you just bought. Show me how you would install the CD-ROM drive on that Mac.
Okay, well previously we have installed plugged in the CD-ROM drive to the computer, which is a one-cable hookup from the drive to the computer, because the Mac already has a built-in SCSI port, which is the interface you need to do that. So now all we have to do is install the software.
And you've got this one installation disk.
One installation disk. Now on this disk are the software drivers and files that the computer needs to recognize and work with the CD-ROM drive. Okay,
so we see an installer icon, so presumably you'll just double-click on that.
Right. Now the install program is running, and I should point out that this is a Macintosh 2CI from 1989. So
5 years ago, a Mac was able to sort of do this on its own. All right, so there's a little installer welcome, and just click OK, I guess. And we click install, and it's doing it. So it says determining which files are needed, so the Mac is sort of figuring out on its own what the conflicts might be, where the files ought to go, all that kind of stuff?
That's correct. It's copying the files it needs from the floppy disk onto the computer's hard disk, puts them in the right places on the disk, and making sure everything is no conflicts with other devices in the computer.
And it didn't ask us any questions like, what do you want to do, and what number is this, and so on. It says it's done. It says restart, so let's just restart the Mac.
Now when the computer restarts, it should recognize the CD-ROM drive and come up with the icon on the desktop.
Okay, we have to restart it because now it's got to look at all these new drivers when it first turns itself on, etc. Right. Why is it so hard on the PC side now compared to the Mac?
Well, PCs have been around since 1981, and frankly, the system is getting a little bit antiquated now, and there's a lot of new devices that weren't around then. There weren't CD-ROM drives in those days. So it takes quite a while to resolve conflicts. You could have DMA channel conflicts, I/O memory conflicts, IRQ interrupt conflicts, software driver conflicts, all kind of things can go wrong.
And you've got to figure out those things. Now, you just tried to install something like this on your PC, right?
Yeah, I got a new PC, and it took me 4 days because I had to install a CD-ROM card, and I had to install a video card, and I had to install a network card, and I had to install a fax modem card, and they kept clashing with each other.
And you're a smart guy.
Supposedly an expert.
And it took you 4 days to do this. All right, now here's the Mac, and it looks happy, huh?
That's right. We have the CD-ROM drive on the desktop, and the window automatically opened, and we're ready to run a CD-ROM.
Okay, now the theory on Plug and Play is it'll be just as simple on a PC now.
That's the goal, make it just as simple on a PC.
Okay, today we'll look at several new solutions to the add-on problem, from Plug and Play to Plug and Tell to no plug at all. Now, the main guys who pushed for this new Plug and Play standard were Microsoft, Intel, and Compaq. We're going to begin with a little Plug and Play tutorial featuring the 3 main companies that really created this new PC standard.
This notebook user is hot docking his machine to a desktop unit, a scene that is currently fiction for most computer users, but it could become reality if the Plug and Play system spreads to personal computers next year. But for Plug and Play to become commonplace, PC hardware and software vendors realize that they need a standard for everyone to agree on. Enter the Plug and Play Association, an industry group that spans the spectrum of computer technologies.
The system manufacturer, like Compaq, has to ensure that they provide all the elements of plug and play, which would include the operating system, which would include a BIOS, which would include add-in boards that are plug and play and that work in their systems. The add-in board vendors have to implement the plug and play logic on their boards so that when they're inserted into the system environment, they're recognized as a plug and play board and are configured accordingly. The BIOS vendors who supply the BIOS to the manufacturers, the PC manufacturers, implement extensions to their standard BIOS offerings to ensure that it supports plug and play.
The future plug and play standard will depend as much on software as on hardware, and that is why the next version of Windows, called Windows 95, will be particularly important.
Well, Windows 95 includes a full implementation of the plug and play architecture in the operating system, and this takes a number of different forms. There's a set of components that we call bus enumerators, which have responsibility for identifying all of the devices attached to each kind of bus. So for example, there's a PCI bus enumerator, and an ISA bus enumerator, and even a SCSI bus enumerator, and so on. And those enumerators identify the devices on their buses. Another component of Windows 95 actually is called a resource arbitrator, which allocates and keeps track of resources such as DMA channels or interrupt request lines, memory ranges, and so on. Another part of Windows 95 is the configuration registry, which manages all of the currently installed configurations.
To the average PC owner today, installing 3 cards at once would probably be unthinkable. But the complete plug-and-play system of the future should have no trouble recognizing its new additions. And current PC owners have not been completely forgotten.
We recognize that a lot of hardware is installed and that people are going to keep using that hardware. So number one, we've worked very, very hard to make the Windows 95 installation process on existing hardware a smooth one. So even if you don't have new plug-and-play hardware, you'll be able to use Windows 95. And in fact, by looking at your existing .ini and .sys files, Windows 95 will install quite smoothly.
For the Computer Chronicles, I'm Victoria Smith.
Now, there was one other major player in the plug-and-play revolution, and that was Phoenix Technologies, the guys who actually designed the BIOS that makes it all happen. Albert Sarai is here from Phoenix Technologies, and also here to show us an add-on card that uses plug-and-play technology is Don Coffin from Future Domain. Albert, let me start with you and ask you to explain what's the hardware we're playing with here.
This is an NEC Image P90, which has an Intel Pentium processor and a Phoenix plug-and-play BIOS.
So we've got a Pentium PC and your plug-and-play BIOS in it. Let's talk about the cards, Don, and this is your Future Domain card. What is it?
This happens to be our plug-and-play SCSI controller, the add-in card that will actually run our CD-ROM so that we can access the CD-ROM application. As you can see, it's a plug-and-play, which means that we have no decisions as far as jumpers and switches to be set for interrupts, I/O ports, etc. for the user. Unlike the prior old cards, which the sound card represents, where there are lots of decisions and things to have to change and play with.
Yeah, this is really the same Sound Blaster card that we were shown at the very beginning of the program, and as you mentioned, it's got all kinds of jumpers over here, so all kinds of decisions I might have to make to figure out what to do. But you're telling me with the plug-and-play card and your plug-and-play BIOS, I don't have to worry about all that stuff.
Correct.
All right, now I want to do that. Well, you saw at the beginning when we had the Macintosh, it's kind of simple to install that CD-ROM drive. Let's install the CD-ROM drive here using plug-and-play and the sound card and show me what happens.
All right.
Okay. So what do we do?
We put the...
So you'll put your controller card in.
Okay. And now if you'll insert the sound card,
and I'll stick in the Sound Blaster card in my slot over here. Okay, both cards are in, so you can turn it on. All right, now, plug-and-play really requires a bunch of different things, doesn't it? Go through what the basic requirements for plug-and-play are, Albert.
In order to have real plug-and-play, you need to have a plug-and-play operating system, plug-and-play add-on cards, and a plug-and-play BIOS.
All right, so you've got your BIOS in here, we've got your card, the operating system. Now, we are not using Windows 95 here, so how we're able to do plug-and-play?
The plug-and-play BIOS is now configuring the add-on card, giving it resources that it needs, and making sure there are no conflicts between the resources that it gives to the card and the resources that are on the old Sound Blaster card.
And if we had Windows 95, how would that be easier?
That would add a couple of things. Number one, Windows 95 automatically adds the drivers that would run this hardware. Now, we will have already had to do that. We've added the drivers for the demonstration. A user will not have to do any of that with a Windows 95. The other thing that Windows 95 will do is it will allow applications to become aware of when resources are taken away. For example, the demonstration that Microsoft did coming into this segment with the docking station. Windows 95 automatically sensed the network when it was plugged, the laptop was plugged into the docking station.
But right now, using BIOS and your card, we're still able to do a lot of the same things right here.
Correct.
All right, so we're up in Program Manager. The cards are in there, and I want you to show me that I can actually play this CD-ROM drive.
All right, we've
now.
actually gone ahead and we've got a Groller's Encyclopedia application. We've installed it. So all I have to do is click on the icon for the Groller's group and bring up the application. And now we're going to go out and access the CD-ROM through the SCSI controller that we just installed, and we will be in our CD-ROM application.
Okay, CD-ROM's running, and I didn't have to figure anything out. So what we did on the Mac, and you've been able to do on the Mac before, we should be able to do with plug and play on a PC.
Right.
And we can do it today.
Yeah.
And it makes it very easy for the users because they don't have to worry about putting jumpers on these plug-and-play cards. And there are no conflicts in the system. Everything is taken care of for them automatically by the system BIOS.
All right, guys, thank you very much. Now, the ideal implementation of plug and play is a complete system that can automatically switch between peripherals without you having to do anything. One of the best examples is the new multimedia PC from Packard Bell. Here to show it to us is Fred Kern of Packard Bell.
Hi,
How you
Stewart.
doing?
Fine, thank you.
Okay, you guys focus on the home user, the person who doesn't want to worry about DMAs, IRQs, any of that stuff. You just want to take it out and do it. So let's say we've just gotten this Packard Bell out of the box, we've plugged in all the basic things, put it in the wall, turned it on. Show me what happens when I start to use the machine.
As soon as the button's pushed, the system will go through its post, and then we'll go into Windows, and then we'll soon go into Navigator. Navigator is the software that allows novice users to get through the system without knowing DOS or Windows or anything about it.
Hold on a second.
Bell's Navigator. Welcome to the main menu of Navigator, the easy way to get to know and use your Packard Bell computer.
All right, so you've got the easiest interface of all, which is somebody talks to you. So I obviously didn't have to install a sound card or anything. The machine says, what do you want me to do, etc.
Right.
So Navigator is an interface you've interposed actually on top of Windows between it and the user.
It's on top of Windows. It accesses all your Windows programs, all your DOS programs.
So the theory is it's easier to use and simpler than Windows.
And it walks you through it. Now, you don't even have to click. You just move your mouse over a button. It tells you what's behind that button. So let's click on the button. Notice it's a single click. I'm now in the Learning Center where I have all my tutorials, my getting started, my help, my troubleshooter. This is what would guide a beginning user through the system. Okay. I also have a software section. That's how I would launch all of my programs. You can see all the programs are listed there. And if it needs a CD, it tells me I have to add a CD to the CD drive.
All right, now let's talk about the plug and play aspects now. This machine comes with the plug and play BIOS in it, right?
That's correct. It's ready to handle any kind of plug and play card that's out there today. Okay, we have the operating system and the plug and play BIOS to support that.
All right, but in addition, you have something called plug and tell. So suppose I have a card like the Sound Blaster card that isn't plug and play. I can use the plug and tell feature here, and I can plug in, and it will tell me what to do with those decisions that have to be made.
The so-called legacy cards, which aren't plug and play, the ISA utility that we have, this ISA configuration utility, will allow me to see what is in my system right now, what channels are being used.
Okay, so I can tell me what cards I have.
I can click on this. Now to show the IRQs, the DMAs, all the memory addresses that are being used.
So hold on a second. So in the simplest case, I mean, it shows me what's going on here and what all these cards are doing, so I could answer the questions myself if I wanted to.
Right. You could see conflicts here if you knew what the parameters were of the card. But if you don't know what those parameters are, you can find them in another feature.
All right, so if I want to be techie, I can go inside, it'll tell me all that stuff. If I just want to install a new card and I just want it to help me, how do I do that?
Okay, let's say we want to add a card and we get a choice here. Let's pick a video card. And let's pick the ATI Graphics Pro Turbo card. Click here. And it's telling me that there are some settings that are different from my factory
There's some work
default.
to be done here.
So let's see what we have. And it's showing me I've got some memory conflicts, I/O port conflicts. So by knowing that, I can configure the card correctly for the system, very little hassle.
All right, so instead of that situation in which it's saying, what IRQ do you want, what DMA do you want, what do you want to do, it says, here's what the situation looks like.
It's presenting it to me right there on the screen.
Okay, so that's plug and tell.
It makes it very simple, right, plug and tell.
Okay, well, plug and play is a new technology for the PC world, but as we've seen, it's been available on the Macintosh for several years and on the Unix platform. We found a fascinating example of the use of plug and play in a network environment at the Barrick Gold Mine near Elko, Nevada.
A visitor to the Barrick Gold Strike mine in northeast Nevada feels like a Lilliputian from Gulliver's Travels entering the land of giants. Giant trucks roll down into a vast pit where mammoth cranes scoop tons of earth from the hillside as though it were dust. It's a world where literally mountains are moved. $500,000 of soil are dug every day, yielding over 4,000 ounces of gold. This year alone, the Gold Strike mine will produce about 1.8 million ounces of gold after an elaborate and expensive process of extraction. What makes it worth the cost to dig, grind, mill, and leach less than an ounce of gold from a ton of dirt? Simply that today, this gleaming precious metal sells for almost $400 an ounce. But even in this world of gigantic proportions, the PC and PC Network have found a place, organizing and scheduling the mine's 24-hour-a-day operations. In 1993, Barrick reorganized its 250 computers into a Unix network based on Sun Microsystems servers.
It was our goal to make sure that we brought together all the separate little pockets of information processing that had grown up across the mine, because on our previous platform we were unable to offer the service to everybody across the mine site. Everybody was doing their own thing, taking reports that had been created in the administration building and rekeying them on a separate PC out there. And of course, people were producing reports that wouldn't crossfoot, the information was different. And so senior management at American Barrick realized that we had to do something to make sure that we got the information correctly throughout the mine site.
Computers are everywhere at Gold Strike, from the purchasing department to the engineering offices to vehicle maintenance sheds. You can also find them in the dispatch tower, where they keep the massive ore trucks moving quickly in and out of the mine pit. But perhaps the most impressive aspect of the Gold Strike PC network is the simplicity of making changes. Adding boards, peripherals, or hard disks requires no outside reconfiguration, no juggling of dip switches or jumpers.
What the plug and play offers for us is the ability to simply bring the machine down at a scheduled PM time, put the new device in the machine, and without having to read and pour through manuals for several hours to figure out what this board does and how we're supposed to tell the operating system to use it, we simply put the device in, turn it back on, reboot it, and the system knows the new device is there, knows what to do with that device.
For the Computer Chronicles, I'm Giles Bateman.
What would happen if you wanted to plug 2 mice into your computer, or 2 joysticks, or 2 monitors? Could you do it? The answer is yes, if you were using something called the Access Bus. Here to explain all that is Peretz Czarnacki of Computer Access Technology. What is the Access Bus? We've been talking about plug and play up until now. What is different about Access Bus?
Access Bus basically is a new standard for plug and play peripheral connectivity. It's a very simple, intuitive plug and play technology. When you plug a new device, immediately the host is notified that a new device is there. The host extracts all the necessary information from the device and can immediately start using the services of this device.
All right, so we have one example here, a simple one. It's 3 different mice that are plugged into this computer right now, and we see them on the screen there, right? There's a red mouse and a blue mouse and a pink mouse, right? And you're saying I could just unplug one of these things in real time and the computer will know what's going on.
Exactly.
So can we try that? So I'll take out your red mouse here, and the computer seems to know, it reconfigured itself, and it says you only have 2 mice now.
Yes.
And can I just plug it right back in real time?
Yes.
Plug and play. All right, and the red mouse is back up there. Now, you have a monitor program in here that actually shows what's going on. Let's take a look at that, Peretz.
Okay, first I'll quit this application. I'm bringing up the monitor. This application basically display what we call the device table. A device table is a list of all the devices that are currently connected to the host computer. You can see on the list here the keyboard, which is the Access Bus keyboard. You can see 3 mice, blue, pink, and red. And the last one is the monitor, which is the NEC latest version of monitor.
So you've got a monitor going through this bus, you've got an extra keyboard going through the bus. Now again, can I just pull one of these out in real time and we'll see what happens?
Yes.
I'll pull out this one. Let's see if it can tell me which one it was.
Okay, I'll refresh the list.
And it tells me there's no more blue mouse.
The blue went out.
And I can in real time just plug this thing back in, huh?
Yes, I'll refresh it again, and
there
the
it
blue
is
is back.
All right, now show me you've got an extra keyboard plugged in at the same time. Can you show me both keyboards are actually alive?
Yes, for this I have to go to kind of word processor.
Okay.
I have ready here the notepad. So basically, I can delete, I can type from the Access Bus keyboard, I can type from the original keyboard.
So that's
here.
the keyboard on the CPU. This is a peripheral keyboard that's running at the same time.
This is Access Bus keyboard, use Access Bus keyboard driver, and you can add more and more keyboards if you need.
Now, you said the monitor itself is going through the Access Bus, so there's an extra connection. This has Access Bus technology inside the monitor. What's the advantage of that?
With this monitor, you can adjust almost all the parameters of the monitor from the computer. You have a control panel, and you can adjust everything.
So it's not just an output device now, it's actually a device which is controllable through the software. Show me the kinds of things you could do.
Okay. This is the image manager. This is a control panel developed specially for Access Bus monitors. I'll show, for example, size and position. This is the original size. I can increase the size of the monitor. I can shrink it. This is done very easily by software. I can easily change the horizontal position. I can move it to the one side. I can move it to another side of the screen.
So having the monitor go through the bus gives you all these software controls over stuff that normally would require screwdrivers or pushing those buttons and so on.
Exactly.
All right, now to get this technology, this is one of your boards, right? If you wanted to get this kind of bus into a desktop?
Yes.
And what is this guy?
This is an external solution that plugs into the parallel port and allows you to add Access Bus capabilities to a laptop or any computer that you want.
So you can get this bus technologies by plugging in these things, and this is what, the example of it on a motherboard?
This is a 46 motherboard that supports Access Bus and with a chip on the motherboard.
And that's your chip in there?
Yes.
Okay, thanks very much.
Thank you.
All right, the simplest answer to connecting up two computer devices is not to have to plug in anything at all. Here to show us JetEye are Fred Rome of Extended Systems and Clayne Anderson of Hewlett-Packard. Guys, we've been talking about plug and play up until now. You have something called point and shoot. What's the difference in point and shoot and plug and play?
I think it has to be ease of use. Pointing and shooting just means you put the devices in line with each other, more or less, and push the button, the data transfers across via infrared technology.
So this is hooking up different devices without wires, without plugs at all?
No wires at all. It's using a new open standard. It works very simply.
This is an open standard, so everybody's talking the same language.
That's right. You're going to find all devices from many different manufacturers using the same standard in the next year.
Okay, Fred, now we have a desktop over here, and this is your infrared transceiver over here?
That's right. That's an external infrared transceiver that attaches to the serial port of the desktop that allows it to communicate via this infrared technology.
Okay, and you've got one built into the notebook there, so open up your OmniBook. And all right, let's start out over here with the desktop and show me how you would get these two guys connected through infrared.
Okay, on the desktop, we use LapLink. And it's just an example of software that could be enabled to work over an infrared link. So this is waiting for a connection, and I've enabled a connection here on the OmniBook.
It just beeped, so they're talking to each other?
They're now connected, and what's happening is they're mapping their drives to one another. So the desktop can access the OmniBook, and the OmniBook can access the desktop. So you see drive C, which is my hard drive, can be accessed right from the desktop. So I've written a press release that I want to put on my Palm Top or portable. I just simply drag it to drive D, and it's copied over.
So just as if this were another drive sitting on the desktop.
That's correct. And the same thing can be done from the OmniBook to the desktop. So if I wanted to install new software here, I could access this floppy drive.
Okay, so we have a file that just moved through infrared from here to here. Now I want to print it. Can I go from the notebook to this DeskJet printer?
That's right. You can use an external adapter, much like what we've used on the desktop, that just simply plugs into the parallel port of the printer. So now we've got the press release here. Let me pull it up and
just stick a piece of paper.
Go ahead and insert the piece of paper.
Okay, so we're now going from laptop to printer.
That's right, using the exact same infrared technology. Two different functions, same interface. So once the printer gets set here, it'll go ahead and the infrared connection will transfer the data. And in fact, it's flashing busy right now.
Okay. Now let's talk about this little guy. Now you've got a palm top over there. Now we could be doing the same thing, going from the notebook to the palm top using the infrared built into both?
That's correct.
All right. Now you also have something else there called Starlink, Claim. What is that?
That's right. Infrared is great for short range, but HP Starlink is designed to provide nationwide coverage. You can receive news, weather, sports, personal messages right into your palm top or your notebook anywhere in the country.
So again, this is using wireless stuff just to go from here to here, you know, a foot apart. That's wireless, same at a kind of point and shoot, but up to some satellite in the sky somewhere.
Yes, linked by a satellite, works anywhere in the country in any populated area.
Okay, thanks a lot. That's it for this week's Computer Chronicles. Remember, if you have any questions about anything you've seen on today's show, if you'd like to suggest topics for future shows,